Hey guys, simplifying some algebraic expressions here. We're going to be combining some like terms and generally getting the idea here so we can move on to variables on both sides equations, I should say. Let's start with some review of vocabulary. Start with a little review here. An algebraic expression is an expression that contains at least one operation and at least one variable. The terms of an algebraic expression are separated by addition or subtraction. So plus signs and minus signs separate terms. 2x is a term, but you don't say 2 and x separately are a term if you see 2x written down. That's one term. Simplify. That means do all the math you can until you can't do any more. So that means you're using the rules of math, and if you're applying the rules of math correctly, then you definitely know you're doing it right. Okay, if you start breaking the rules and doing things weird, then obviously you're not going to get the right answers. So we can only add things that can be added. We can only multiply, etc., etc. But we'll get the hang of it the more we practice. Review here, a little bit more review. Like terms have the same variable raised to the same power. Same variable, same exponent, that's like terms. The numerical part of a term that contains a variable is called a coefficient. I've been putting that on a lot of your assessments because we really need to know that. We're still struggling with that vocabulary. So 2x, the 2, that's your coefficient right there, 2. A term without a variable, that's called a constant, and all constants are like terms. So if two things that are constants are like terms to one another. All right, so let's identify some like terms in these expressions. So let's start with this first one here. We got 3x, and the like term to that would be minus 3x. So it's like a negative 3x. Remember, negative 7x. Negative 7x and minus 7x are the same thing. So 3x and minus 7x are the like terms here. Plus 2 minus 8. So plus 2 and negative 8 are both constants. So in this case, those would be like terms. On the next one, you have minus 2x or negative 2x and minus 3x. Those are like terms. But the y, that is not. Plus 8y, not a like term. All right. Last one down here, 3y plus 6y, like terms. But y squared and minus 2y, not like term. Or minus 2, excuse me, not like terms. Because y squared has an exponent on it. It's a completely different value from y. Think if y was 2, y squared would be 4. So I definitely can't add those together. Oh, sorry about that. She's too fast for me. I didn't get to the pause button before she started talking. So we'll just leave it in there. All right, so there you go. There's our like terms being combined. Or like terms identified. Now let's work on combining them. Combining like terms in an expression is really just an exercise in adding integers, guys. That's really all we have to do here. All right, so let's identify our like terms first. 4x and 2x. 4x and 2x I can add together. Add the 4 and the 2. You get 6, tack the x back on. And then we still have a plus 6 in the expression. And that is simplified. There is nothing else I can do to this because I've done all the math I'm allowed to do. I can't add this together right here. Because if I try to add those and make it 12x, you don't know what x is. And there's only one value of x for which that would be true if x was 1, but we don't know what x is. The whole point is that x could be any value that I could plug in if I wanted to. So 6x plus 6 is as simple as it gets, guys. Do the next one. If you think you're getting the hang of it, pause it. Try it on your own. 5n and minus n. And that's 5n minus how many n? 1n. 5 minus 1 is 4. So 4n. And then my other pair of like terms here is plus 2 and minus 6. That's like positive 2 and negative 6, which equals negative 4 when you add them together. I want you to work on seeing that minus 6 as a negative 6. Minus 6, negative 6, same idea.
Elementary Odyssey.
I guess we're going to leave that one in there too. Sorry, guys. All right. Like terms, negative 6y. This is what happens when I make videos at school. Negative 6y plus 3 minus 5y plus 7. Negative 6y and minus 5y are like terms. Now be careful with this one. That's like a negative 6 and a negative 5. And we add them together and get negative 11. Negative 6, negative 5. Add them together, get negative 11. Your other two like terms are both positive in this one. So we have positive 3 and positive 7. Giving me positive 10 when I add them together. Okay, so combining like terms. So if you have a variable and a constant in them, you're often going to end up with two terms in your answer. Yes, that's as simple as they get. Remember, you cannot go any further than that. Okay, recall your distributive property. Recall with the distributive property. A times B is AB, and A times C is AC. Now, if they were both numbers, of course, we could then add them together. But what we'll see here is that we're using algebraic expressions with the distributive property. And sadly, I'm going to have to wait and record the rest of this video during my lunchtime. So we're going to do some activities in class today that you might find fun. We'll see. Hopefully, you can tell me after the fact that they were. And I am back. All right. All right, so now we're going to simplify these expressions using our distributive property. We didn't get to do quite as much in class as I would have liked with simplifying expressions, but at the moment, I just want you to roll with what we've got. It'll start getting easier as we go through these problems. Okay, so this first one is 3 times the quantity x plus 2. And again, you're distributing. So pass out the 3 to the parts in the parentheses, like you distribute flyers. Like we distributed the newspaper this morning. Like I distribute the things that I pass out to you. Okay? So we have 3 times x, which is 3x. Do not put a symbol in between them. Plus 3 times 2, which is 6. 3x plus 6. And that's what we should have for that expression. 3x plus 6. All right, for the next one, we have 2 times the quantity 3y minus 5. So we have 2 times 3y. So 2 times 3, and then times y, so 2 times 3y, and then minus 2 times 5. So 2 times 3y is 2 times 3 is 6. Tack the y back on. And 2 times minus 5 is like a 2 times a negative 5 is negative 10, or minus 10. All right, last one on this page. 5 times a negative 2n plus 5 times 7. And then we got something else hanging on at the end here. So let's distribute first. 5 times, switch the colors so that I want to keep it uniform here. 5 times negative 2, negative 10. So 5 times negative 2n is negative 10n. 5 times 7 is 35, so plus 35. And then I have plus 2n minus 3. So now I've got to go back to thinking about my like terms. So negative 10n and plus 2n. That comes out to be negative 2 plus 10 is negative 8n. And then you also have positive 35 minus 3. 35 minus 3 is a positive 32, so plus 32. Let's do some more distributive property problems. Okay, these differ a little bit. This time, the number I'm multiplying, this factor out front that I'm multiplying by, is a negative. So this is going to change things a little bit. It's still distributing, so it's still negative 3 times x and negative 3 times a plus 9. But negative 3 times x, that's negative 3x. Negative 3 times a positive 9 is like negative times positive. It gives us a negative 27. Negative 27, so minus 27. So we get minus 3x, or negative 3x, minus 27. The next one has a negative out front as well. So negative 4 times negative 2n, and negative 4 times minus 8. Well, a negative times a negative is a positive. 4 times 2, 8, so 8n. And a negative times a minus is also a negative times a negative, which is a positive. 4 times 8, 32. And that should make sense, because when I multiply a negative times two things that have negatives or minuses out front, we get two positive things. There we go. Two positive terms, if we're using the right vocab here. All right, for the next one, we also have to distribute, but then we have to combine like terms. So let's distribute first, combine like terms afterwards, because we do have to get rid of those parentheses first. And this, if you think about PEMDAS, that is actually not a parentheses step. It's really a multiplying step. We have to multiply first before we can add and subtract. So we're going to distribute. Nothing will happen to the 4a minus 6, so I'll just go ahead and write that first. Plus 2 times a plus 2a. Oh, that's an n. That's an n, Miss LeCompte, not an a. There we go. 2a. And then plus 2 times a minus 1 is minus 2, or negative 2. Now I've got to go through and combine my like terms. 4a plus 2a. 4a plus 2a is going to be 6a. 4 plus 2, 6. Tack on the a. And then we have minus 6 minus 2. Well, negative 6 and negative 2 adds up to negative 8, or minus 8. So the expression for that one comes out in the end to 6a minus 8. All right, if you think you've got the hang of this, why don't you take this last one, and why don't you try it without watching me do it, and then start the video again. So pause your video and try it, if you are so inclined. See if you get it right. All right, so this is another one where we have to distribute first, then combine like terms. So nothing's happening to my 7y plus 3 to begin with. I'll go ahead and write those. Minus 4 times 2y is going to be minus 8y. Negative times positive is a negative, so a minus times a positive is a minus. Negative 4 times a minus 1, negative times negative is a positive 4. Again, see this as a negative, see this as a negative. Negative times negative, positive. Now I got to combine like terms. 7y and minus 8y. 7 minus 8 is negative 1. So negative 1y is just negative y. You don't need to put the 1 in there. And finally, plus 3 plus 4. 3 and 4 makes 7. So negative y plus 7. And you'll be working some more with simplifying expressions, using distributive property, and so on, combining like terms. You'll be working on that in class next time I see you. See you guys in class.